Hello ladies and gentlemen, today we're going to be reviewing Unit 2, which is the Population and Migration Unit. So I'm going to go through some of the concepts that are covered within this unit, and we're going to start with population distribution. So population distribution is pretty much saying where people live. This is where humans are distributed on the earth. And the word ecumene is used to describe where humans live. This is the inhabited part of the world by humans. So throughout history, there are certain places that humans tended to settle down, and even coming into modern times, we are settling in large parts of the earth, but there are certain places that we avoid. So think of this as humans are going to avoid places that are too hot, too cold, too wet, too dry, and too rugged or mountainous. So therefore, the places that are most densely populated are going to be places that are going to be easier to settle. Notice humans tend to live coastal areas, plains regions, and we avoid really cold areas. So, northern Canada, northern Russia. Places that are too wet are equatorial regions, like here in Brazil. Too dry, here's the Sahara Desert in Africa. And we also have in this region, this is a high region as well here. Antarctica's not even on here, but that's obviously too cold. There's lots of cool population data on this website, so I recommend that you check it out. Something we need to be able to do is look at population at different scales of analysis. Remember, scale of analysis from local to global. This is a map showing you the total population by the country scale, the national scale. So it lists the country plus the total population of that. This is also an example of a cartogram where it kind of distorts the shape and the size of places based on their level of population. Clearly you can see China and India are the two top most populated countries. We oftentimes see population distribution on a dot map that looks like this. So you get a better idea. This is just at a scale with the dot map, where this is a country scale. Now, to understand one thing, we need to look at population density. So there's three different types of population density. There's arithmetic, physiological, and agricultural density. The map you're seeing here is an example of an arithmetic density. This is the basic form. You take the total population divided by the land area of that country, and you get the population density of people per square mile or square kilometer. But there are other ways that we need to look at density because it can give us more information. So the arithmetic is the basic one. Physiological density, which is listed here, gives you an idea of what is the population based on the amount of arable land in that country. So it could be that a country has a really high physiological density. Egypt is always a great example. Egypt is mostly desert, so there's not a lot of arable land. And so their physiological density is high because most people are concentrated in the arable parts of that country, which is along the Nile River. There's another type of density known as agricultural density, and this gives you the total number of farmers per unit of arable land. This is important because in less developed countries, there are a lot of people who their livelihood is growing land. And so it's important to know that, is there enough land to support the amount of people who are farmers? So that gives you that number, the agricultural density. When we study population, there's lots of statistics that we use. And the study of population is called demography, the study of humans. But there are several statistics. And one of them is the crude birth rate. Sometimes you just call it birth rate. This is number of births per 1,000, and then you have the crude death rate. And if you take birth rate minus death rate, it gives you the natural increase, and that's a percentage. So this is how much a country is growing, birth rate minus death rate. We also need to look at total fertility rate. This is about, on average, how many babies per woman in a society. The infant mortality rate is another statistic we look at. Number of deaths, infant deaths per 1,000 live births, and life expectancy. So all these terms we've used several times in this class, so it should be fairly familiar to you. So topic 2.4 is population dynamics. Social, cultural, political, and economic factors influence fertility, mortality, and migration rates. One of the first things we did with this unit was something called the Baby-O-Matic, where remember you did a little quiz and it calculated about how many kids you would have. Most people average 2, and that's the average in the United States. So what we look at is that population is definitely going to be influenced by several factors. So what kind of social factors can influence population? Well, gender roles. In the family, is the mom supposed to stay home and take care of family? Is that the expectation? Is there a presence of family planning? Do families actually figure out how many kids they want and they work around that? The level of education can also dictate on average, the fertility rate in a country. So we talked about if there's lower levels of education, let's say a female only gets to middle school or elementary, primary school rate of education, she's probably going to end up marrying sooner and having more kids because she's starting at a younger age. But also the gender roles kind of play into that as well. She may not have a choice in that. So cultural factors include also gender roles, but also religious beliefs, because some religious beliefs they don't really allow family planning. Political. So the thing about the government is that if a country has too high of a fertility rate and they're trying to adjust to that, they may have population policies put into place. But it could be the opposite, where a country has not a high enough birth rate, and therefore they have pronatalist policies. This all ties into migration as well, because some countries that perhaps need workers because they have an aging population, they may have immigration where they allow what's called a guest worker, where they have people come in and do jobs that country can't provide on its own. So they attract outsiders to come work. Germany is an example of that. They had a lot of people coming from Turkey as what they called guest workers. And they said, okay, you come here, work for a little bit, then go back home. Well, usually what ends up happening is they don't go back home, and they stay and they form a new community. There are also economic factors that influence the fertility, mortality, and migration rates. So the level of development. So we clearly see that the more developed a country, they tend to have lower birth rates, lower fertility rates. Whereas poorer countries, think sub-Saharan Africa, tend to have, they're less economically developed, but they also have larger families. So think about more developed countries. Kids are expensive. They're not used as farm workers or babysitters. Kids are oftentimes seen as kind of an expense, and therefore families choose to have less kids. That's happening in China right now. The one-child policy worked really well to the point where families decide, okay, we're still going to have one kid, even though they're now encouraged to have more than one, but it's too expensive to have more than one. This is a map showing you the population growth of countries around the world, and the darker turquoise color is going to be the highest growth rate. So the more of the turquoise or green color, those have higher growth rates. So notice the parts of the world, sub-Saharan Africa, Middle East, a lot of these are also less developed countries. So you have to think about what kind of problems are those countries going to experience now that they have a growing population. And that is a concern for sure. So topic 2.2 is consequences of population distribution. This comes straight from College Board. Population distribution and density affect political, economic, and social processes, including the provision of services such as medical care. So I have a picture of a map of Texas. This is organized by county, but it shows you the population density in all parts of Texas. You can clearly see San Antonio, Austin, Houston, Dallas, Fort Worth. So the cities kind of stand out to you. So where people live is going to affect what kind of resources we have in that particular area. And also, if we start to see a growing population, we're going to need more services such as medical care. So remember that hospital bed density number we looked at with the data analysis a while back? Well, clearly we're going to need more of those types of things in the redder areas because you have a bigger population. So population distribution and density also affect the environment and natural resources, which is known as carrying capacity. Can the environment handle that population? So if you look at Texas, you can clearly see that West Texas and the Panhandle have a very low population density. And if you've ever driven those areas, you may also see, especially when you go west, that it gets drier and drier. So the carrying capacity in West Texas is not going to be able to handle as dense of a population as if you go further east. Okay, this is the part of the state that gets more rainfall and can handle a growing population. The concern is, though, that a lot of people are moving to Texas, and especially along this, what we call the I-35 corridor, where a lot of people are moving. And so the concern is if that population continues to grow, we have this strain on water supply. We rely on aquifer for our city water, so we might have to have watering restrictions. And as that population grows, those restrictions might increase. So just be aware of those types of impacts that growing populations can have on the environment. Topic 2.6 is about the Malthusian theory. Now, Thomas Malthus was an economist, late 1700s, almost 1800s, and his basic theory was that the population is going to outgrow the food supply, and there's going to be natural checks on the population, such as famine, war, disease, that will kind of balance it out. Pretty much he was saying, we're going to run out of food. Well, there are lots of critiques, because what didn't happen is we continue to grow in population and we didn't run out of food. And that's because of what humans were able to do to modify the environment, and especially because of things like the Green Revolution, where we were able to grow more food on the same amount of land, more efficiently, pest resistant, that kind of thing. And so we were able to kind of handle the growth. And so that is a main critique of Malthusian theory. Now, there are groups of people known as neo-Malthusians who are the new Malthus, and they kind of agree with the same thing. They're saying, well, now that's going to happen again. We're going to run out of food supply. We're growing too fast. So that's a neo-Malthusian would be the type of person that would support anti-natalist policies, who would say people should have less kids. Now, you have a copy of this somewhere in your notes where you filled out a chart. This is the famous demographic transition model. So the demographic transition model is the stages that a country would go through in the process of their population growth. So we think of it as on like a country level, and there are 5 stages of the demographic transition. So if you look at the different parts, you're going to have to break it down, and we did this in class. So breaking it down, there are several things shown on here. There's the death rate, which is this black line. There's the birth rate, which is the one up here on top, kind of blue. And we're going to ignore this down here, the total population. I think that gets a little bit confusing. But see, the birth rate minus the death rate equals natural increase. So natural increase is that space in between. And that space in between is showing you how much that particular place will be growing. So throughout history, most of the world was in stage 1 of the demographic transition. We had a high birth rate, high death rate, not a lot of population growth. So throughout history in Earth, we really didn't have a booming population. We kind of maintained steady because of high birth rates and high death rates. So high death rates, well, things like disease, lack of sanitation, we did not have vaccines, all those things would keep the death rate high. Now, as time progressed, humans started to become more sanitary. Humans also, if you notice, the death rate in stage 2 drops very, very rapidly. So humans are also going to come up with improvements in medical care, cleaner water, and so therefore you have a lower dropping death rate, and that space in between is the natural increase, and it's a very big space in between. So that means those are the parts of the world, if a country is in stage 2 of the demographic transition, which there's not very many in the world today, they have a really rapid growing population. And that is a concern because they're probably not, they're a less developed country, they're not industrialized, and so that's going to lead to problems within that country. Now, over time, the birth rate starts to drop. So what creates a dropping in birth rate? So the chart says it. So that has a lot to do with social reasons, and maybe there are fewer children needed to work on the farm. So you start to see where kids are getting expensive and families have less, or there's more family planning. So the birth rate drops, but if you're in stage 3, it's still going to be a pretty significant growth in population. Now, countries like the United States would reach is in stage 4 of the demographic transition, where both birth rates and death rates are low, and therefore the natural increase is also low. And if you get to the point where the birth rates drop very significantly, even below replacement levels, like you see in places like South Korea, then they reach the stage 5 of the demographic transition, where it's possible that they're going to have a declining population. And so these are the countries that will, Japan is an example, that will maybe have pro-natalist policies where they want people to have more kids. These are countries that may have to change their immigration policies because they need people to come in to make up for that decreasing population. So that's the demographic transition model. This is what stages that a country goes through in the changes in their population growth rates. To tie into that is something called the epidemiologic transition. So I don't know if you remember learning this, you hear a lot now about the epidemic. So here's a couple of vocabulary terms that tie into it. Epidemiologists, can't even say it, epidemiologists, study infectious diseases. And so when some infectious diseases have become worldwide, that's called a pandemic. Okay, when it's regional, it's called an epidemic. And if you hear that word endemic, that means that the disease is particular to a local area. So, for example, coronavirus is a pandemic. Ebola, several years ago, which still happens now, is an epidemic. It's regional. So the thing about the epidemiologic transition is that this is looking at specifically the death rate. So the black line on here. And this is telling you what is the causes for the death rate. So in the early stages, the death rate is because of infectious diseases, because these are places that maybe lack vaccines or don't have proper sanitation, clean water, that kind of thing. As countries reach stages 3, 4, and 5, we see the death rate has dropped significantly. And the more likely reason for the death rate is because of chronic diseases, because people are living longer. They're more old age types of diseases like heart disease and cancer. So that's the epidemiologic transition. One thing you need to be familiar with is population pyramids and how you can use these to look at what a country possibly needs or a city possibly needs, such as goods and services. I suggest that you click on this link and check out this TED video. We did watch this in class. We went over this. Also, I had you, I think, draw this out. And if you look at different shapes of the population pyramids, and that's an example of a population pyramid right here, but the different shapes can give you an idea of what that country is experiencing. So if you have a really wide base, that means you have a lot of kids, babies, kids. And those are going to be rapidly growing populations because when they get to childbearing age, they're going to have kids and that is going to continue to rapidly grow. This is typically your poor countries. The box shape, the United States fits this shape as a pretty steady population. This is kind of where you want to be. And the cup shape would be an indicator of an aging population because you have a wider top part to the pyramid, which shows that more and more people are going into being elderly. So this is a Naples, Florida population pyramid, and we saw this in class, and if you don't know anything about Naples, Florida, it is a big retirement community, and you can see that this one is a unique looking population pyramid. So what does this, when you look at this, what does this tell you about future needs? Well, if you look at the age ranges of what people are, a lot of people are already at retirement age. So you know, when you get older, you probably have more medical problems. So you may need more specific hospital services. You may need more, perhaps, retirement communities. You may need more mortuary services. So that's the kind of thing that a population pyramid could tell you. You're not really going to need more schools, right? So this is something to be considering when you're looking at population pyramids. Now, population policies are government efforts to change population growth. And so a country with an aging population will probably have pro-natalist policies, or which is also known as expansive. They want to grow their population. Anti-natalists are also called restrictive. So they want to limit the number of births in that particular place. So depending on the situation of the country, they may have one or the other. And a lot of countries don't have anything. In the United States, we have no population policies. So the whole thing is that you're going to need to be able to explain the intent and the effects of various population and immigration policies on population size and composition. So China's a great example because they had an anti-natalist policy, the one-child policy, which they were really restrictive on how many children a woman could have. One was a limit. There were exceptions, and depending on where you live in China, cities, they were really going to be a little bit more strict because the cities could feel that population crunch. And so it worked so well that they actually are now afraid of this shrinking population. And if you have a shrinking population, well, then you may have less of a workforce, which is going to affect you economically. And when those people who are working then get older, then you're going to have a big aging population. So a concern with countries such as Japan and for the future, perhaps China, is the concern of an aging population. So you're needing to explain the causes and consequences of an aging population. So I'm going to go over a couple things. So for example, this was what you did with the case study. So a lot of you figured this out. Economic consequences of an aging population. Well, you're going to have a shrinking economy because you're going to have less people actually in the workforce. Some political consequences. Well, governments may actually start to put in place pro-natalist policies because they need to increase the workforce and the future workforce, and they don't want their economy to shrink. But the government's also may change immigration laws. So Japan has pretty strict immigration laws. They're pretty limited on who could come in and work in the country. Because they have an aging population, they're starting to kind of relax some of those immigration laws, and that's going to change the population dynamics of that particular country. Okay, so I zipped through the population unit. If you have any questions specifically, please let me know, and I hope this helped you out. Thank you.